Well, welcome everybody. On a Friday afternoon, I'm surprised how many people showed up for this session. So yeah, I'm honored. Thank you so much. Today I'm going to talk about everything related to data encryption and integrity in Azure SQL. My name is Peter. I'm a program manager in the data platform security team at Microsoft. So my team is managing all the security features inside SQL Server, Azure SQL DB, and managed instance, and also the other flavors that we have, like Cosmos DB, PostgreSQL. And I'm the PM for two features of Always Encrypted and Ledger. And these are actually two topics where we're going to talk about today. So basically, I want to talk about three topics. First of all, TD and the investments that we have done in transparent data encryption. Then a big part about Always Encrypted, how you can use it, and again, also the new investments that we have done. We did a bunch of announcements this week here at PASS about Always Encrypted. And last but not least, I'm also going to talk about data integrity. It's not really related to encryption, but everything, yeah. How can you be sure that your data can be fully trusted? So I'm going to talk about Ledger, yeah? Sometimes it can be kind of like difficult. If it's too hard or if I go too fast, let me know if you don't understand. If you have questions, we have 75 minutes, so should be sufficient. Okay? Right, let's get started with TD. Where are these features used? So data at rest, this is where TD comes into place. I'll talk about that immediately more into detail. Then we have data in transit, so the wire or the transactions that are happening between your application and your database, so the connection should also be encrypted. That is done by TLS, or Transport Layer Security. This is something I'm not going to talk about today. And then we have data in use, where you can use column encryption using Always Encrypted. So I'm going to talk about TD and Always Encrypted, right? Now, let's get started with TD. I already heard you, somebody is using TD. Anybody else is using TD? All right, bunch of people. Now, what is TD? For those who don't know, TD stands for Transparent Data Encryption, which means, like it said, it is completely transparent for your application. So what we're doing, encryption at rest, which means that if SQL Server or your Azure SQL DB needs to write something to the disk under the covers, before it is written to the disk, we are going to encrypt it for you, and we're going to store it in an encrypted format on disk. Yeah? If SQL Server needs to read something from the disk, before it loads it into memory, it's going to decrypt that information and loads it in plain text inside the memory. So, as I said, it's completely transparent for your application. You don't need to make any changes. TD does it automatically for you, right? It is enabled by default, so from the moment that you create an Azure SQL DB or a database in managed instance, we enable TD for you. You can switch it off, which we do not recommend, but it's something you can do. And as an extra, of course, since your data files are encrypted, it means that your backup files, your transaction log files, everything else is also automatically going to be encrypted. Make sense? Good. All right, so how does Always Encrypted work? So you have your Azure SQL database, right? And we need to configure, or we need to have what we call a database encryption key. And that encryption key is going to perform the decryption and the encryption of your information on disk, right? So that database encryption key needs to be encrypted again by what we call a TD protector. Yeah? And that TD protector can be two different types. It can be a customer managed key, or CMK, and it can be a system managed key. Does anybody know the difference between the two? Yeah. Yes. Very good, correct. Let me repeat your answer because it's good. So customer managed key is you manage the key. So you store your certificate in the Azure Key Vault. You are concerned about the key rotation. We don't touch your key. System managed key is where the customers say to Microsoft, I don't care. You manage the key for me. Microsoft is doing the automatic key rotation. By default, when you enable TD or when it is enabled, we activate system managed key. The customers, they can easily change that to customer managed key. Yeah. So under the covers, some extra security. If you're configuring a general purpose or a basics tier or a standard tier, under the covers we're using remote Azure storage. And that storage is also automatically encrypted, which means if you have TDE and you're using one of these service tiers, you have actually double encryption of your data, once by TDE and then once again from the storage. If you're using business critical or premium, then under the covers we're using local storage, local SSD disks, and then you just have the encryption of TDE, which means if you would disable TDE on a business critical or a premium edition, that means that your data is not encrypted at all on disk. So that's something we definitely do not recommend. All right? Now, talking about these customer managed keys, as I said, the customer is completely responsible for the key. You need to configure it in an Azure Key Vault, and you have to, and it requires a managed identity for Azure SQL to access those keys. And what are the permissions that you need to configure? That is get, get to retrieve the public key. Then we have wrap key and unwrap key to enable or to encrypt and decrypt the database encryption key. All right? Is there anybody using CMK already? No? All right. Oh, you do? Okay, a couple of people. Right. Now, these CMKs or TDE, you had to configure that on the server level, right? Which means that all the databases that you are creating on your server are inheriting TDE and are inheriting this customer managed key. Now, what we have introduced last month, not this month, but last month, is database level customer managed key. So we're going to overrule the settings of your server, and you can now configure a CMK, so a customer level key on database level. This was a high demand by ISVs, because ISVs, they create their databases for different customers, and the customers had the requirement where they say, yeah, but if the ISV is managing our keys, we don't want that. We want to manage our own keys, right? So that's why we came up with that solution to where it is possible to have your customer managed keys on database level. Yeah? It requires the same type of key or certificate, and it also supports cross-tenant. And what I mean by cross-tenant is this example. So you have the ISV tenant, and then you have the customer tenant. So you can now configure a key that is stored in the Azure Key Vault on the customer tenant. You can that create on a database which is stored in the ISV tenant, which means that at that point, the customer is, again, in control of the key and not the ISV or not Microsoft. Everybody still with me? Yeah? Cool. Let me quickly show you how you can configure that, right? Let me jump to the portal here. And I have here a database called Demo CMK. People in the back, this is visible? Yeah, all right, cool. So if we go to here on the left, sorry, we have now data encryption. Previously, it was called transparent data encryption. Now it's called data encryption. I will tell you immediately why. Because now we have two options, transparent data encryption, and we have always encrypted, where I come back to immediately. So as you can see here, TDE is enabled. That's fine. And I'm using the server level encryption key. That's good. Now, let's configure the customer level or database level key. So the first thing that you need to do is you need to create a user managed identity that you need to link to your database. The reason why we need that is because the database needs to have access to the Azure Key Vault to fetch the key, right? So that's what I'm going to do. So configure. I need to click add here, and then I have database UMI, and I'm going to add it. And just click apply. That's one. And then secondly, of course, I need to select my key. So which key am I going to use? So I just click change key here. I go to my key vault, and the key vault that I'm going to use is this one. And under the key vault, I have here a database CMK. So that is my certificate that is stored in the Azure Key Vault. This is the version. Click Select. I can also opt in here to have automatic key rotation. So that is also a possibility. And that's it. Then the only thing you need to do is just click Save, and you have configured your database customer managed key. That's how easy it is. All right.
Talk about the auto-rotate key. How does that spark integration with the key vault?
Yes.
It's going to rotate in the key vault, which is the feature.
Yes, so if it rotates in the key vault, it will automatically be updated here as well.
And so it could be driven from whether I rotate it from the key vault itself or from here?
No, from here. Yeah, this is from here. Yeah, that's right. Okay, any questions? Yes, sir.
Are those certificates auto-renewable, or they have to be renewed every year manually?
You have to renew them manually. Okay. Yeah, yeah. You can specify no end date, but yeah, we recommend to specify an end date and then renew it yourself. If you don't want to do that, then you need to go for system version, where we will renew the certificates for you. All right. Cool. All right. So that was what we have implemented in TDE, which is brand new. Okay, let's talk about the second encryption option that we have, which is always encrypted. Are there anybody in the room that's already using always encrypted? One person, two, three. All right, okay, cool. So what is always encrypted? The motivation that we had is we want to enable our customers to store confidential information in the cloud, in their databases, but they still need to be able to use that data even though it is encrypted, right? So always encrypted is where we protect sensitive information on a column level. So you will need to specify which columns you would like to encrypt, and that column can only be visible by persons or applications that can be trusted, which means, for example, a DBA that works in the company doesn't need to have access to that data, right? If they can work with the data, that's fine, but they don't need to see that data. And that's the whole purpose of always encrypted. Protect your data from malicious DBAs, malicious insiders, malware, you name it. All right, you're laughing. Okay. All right, so how does always encrypted work? Let me have a laser pointer here. So we started our journey in SQL Server 2016, and Always Encrypted is also available in Azure SQL DB managed instance and also in Cosmos DB. Still, this is also available in SQL Server 2022. Now, how does Always Encrypted work? You have here on the left side your application, which is considered as trusted. Everything outside the application is considered as non-trusted. So the network, the database engine, the DBAs, the operating system administrators is considered as non-trusted. So how does it work? Your client application sends a query to your database, which is in plain text. The client driver is going to encrypt your parameterized queries and is going to send it in ciphertext over the wire to the database engine. The database engine knows that encrypted information. It will retrieve that information for you, and it will send it back to the application in encrypted format. The client driver will then decrypt that information and will show it again in plain text in your application. Pretty cool, no? Now, the problem with the first version of Always Encrypted was that you were quite limited in what you could do with an encrypted column. And what I mean by that is, for example, if you want to use an encrypted column in your where clause, the only thing that we supported was equality. So you could only say where encrypted column equals a specific value. So we were quite limited there, yeah. On top of that, it had to be deterministic encryption, and you couldn't use randomized. So a good first version, but not really flexible. Now, what we did, we improved our Always Encrypted, and we created a second version, which is called Always Encrypted with Secure Enclaves. That is available in SQL Server 2019 and 2022, and in Azure SQL Database, not yet in managed instance. So we're working on that. Now, the principle is exactly the same, so you still have your application here, but now, on top of that, you also have a secure enclave. And what is a secure enclave? You should consider it as a black box of memory where nobody has actually access to. Yeah? So what happens is the database engine is going to delegate operations on encrypted data to the enclave, which means that it can be decrypted in a secure way in the enclave, since nobody actually has access to that enclave, right? Now, by leveraging that enclave, it means that we can get more flexibility, which means we can now do rich computation queries on encrypted columns. So in your where clause, instead of only using equality, you can now use like, larger than, smaller than. You can use in between. We can use an index on an encrypted column, which was previously not possible. And you can also do order by on an encrypted column. Yeah? Question?
You just mentioned there is a column level encryption. So how much it affect the performance?
Yes. The question is, how much effect do you have on performance when you use encryption? We did some extensive testing, and you get, of course, well, when you enable a security feature, you get a performance impact. It depends, of course, always in SQL on your workload, how many columns that you are encrypting, how many data you have, how many queries you are doing on encrypted columns. So it's hard to tell how much impact it has. That is something you will need to test on your own, but for sure you will have some impact. Yeah. Yes, sir. Yeah, the question is, will this have an impact on the memory? No, this is a completely different type. This has nothing to do with the memory configuration at all. No, no. Another advantage that you have with using these enclave types is end-place encryption. So let's assume that you have a table and you want to start an initial encryption. In the first version, what we had to do, we need to extract all the data outside of your database, do the encryption on the application side, and then push it back in. Yeah? Now, with the enclave, we don't need to do that. Your database or your data can stay inside your database. We just use the enclave to do the initial encryption. So it's much faster. The same for key rotation. The data can stay inside of your database, and we don't need to extract that anymore. Okay? Make sense? Yes, sir. The question is, where is the application located, right? Is it in Azure? Can it be on-prem? Can it be in a VM? It doesn't really matter. I will show a demo immediately where I use a web application which is stored in Azure, but this can easily be stored also on a virtual machine or even on an on-prem server.
The connection is a plain text. If somebody does man in the middle over there,
No. The connection is not in plain text. The client driver is on your application server, right? So from the moment that the information leaves your application, the information will be in ciphertext. So everything that is happening inside the application is considered as trusted. Also the people that are using it. Yeah? All right? Okay. How do we secure that enclave? And you have two possibilities. Or use hardware, which is called the Intel Software Guarded Extension, or Intel SGX. So in Azure SQL DB, if you want to use hardware under the covers, you will need to create a specific type of database called the DC series. And if you configure that under the covers, we're going to create a virtual machine that is using that SGX enclave. What is new in SGX enclave is the 40 physical vCores. Previously, you could only have a maximum of 8 vCores we announced this week that you can now configure up to 40 vCores, which allows customers with high load and that requires a lot of CPU and memory can also now use the DC series. Yeah. What also is something else that we've announced this week is VBS enclaves, or virtualization-based security. So it's software-based, which means there's no hardware dependency. You can use whatever database you would like to use. Yeah? It can be serverless, can be vCore. There's also no limitations on the amount of vCores. You can go, I think the maximum now is 128 vCores, right? And it's available in all regions. So if you look at the number of regions that we have available for SGX, it's quite limited. So it's only East and West US, Europe, Canada, UK South, and Southeast Asia. If you would require SGX in a region that you don't see available here, give me a call or send me an email, and we can enable that region for you if you have a good use case. All right? Now, you're probably wondering, now, what is the difference? What should I choose? Should I go for SGX enclaves, or should I go for VBS enclaves? Well, the thing is, if you do not trust Microsoft, then you have to go for SGX enclaves. Why? Because VBS enclaves does not protect you from attacks from the host OS. So since we're hosting the operating system, like I said, bluntly said, if you do not trust Microsoft, then you have to go for SGX. If you just want to protect your data from malicious insiders, DBAs, whatever, and you trust us, you trust Microsoft, then for sure you can go for VBS enclaves. It's completely for free. SGX enclaves is a little bit more expensive because you have that specific hardware under the covers. Question?
VBS is not for the on-prem servers, right?
VBS is, sorry?
VBS is like not for the on-prem servers, like SQL 19 or
For SQL, this is Azure SQL Database. For SQL Server, the only enclave that you have there is VBS enclaves. SGX enclaves is something we do not support in SQL Server. Right? Okay. Yes, sir.
When you were talking about trusting Microsoft, do they give security clearances to all of their tech workers that have access to the OS and the hardware?
Mm-hmm. If we do that.
Yeah, do you do background investigations and security clearances on all your tech?
That is something I don't know, sir. That's a good question. But I don't know. I don't know, to be honest. All right. Cool. You want to see that in action? Yeah? All right. This is not recorded, so let's go and let's hope that everything works as expected. All right. So I'm using a simple website, which is from the Contoso HR department. And as you can see, that website contains pretty sensitive information. I have social security numbers. I have salaries, stuff like that. I can use the sliders here. I can use the search box to search on specific social security numbers, right? So if I go to the database that I'm using under the covers, so I am using an Azure SQL database called Contoso HR, and I'm logged in as a DBA for the moment. So when I run this, as you can see, I can also see the plain text. That's not what we want. Right? So I will go over the different steps to show you how you can enable always encrypted and to hopefully show you how easy it is to implement this. All right? So first thing that you need to do is we want an enclave, right? So if I go to my portal and I go to my database here called Contoso HR, we have a new tab. So in the data encryption, we have now always encrypted. And what you can do here, you can easily switch on that enclave, right? So I'm going to use VBS enclaves for this demo, not SGX enclaves. So I just switch it on and click Save. This is available in the portal. You can do this automatically when you create a new database. You can do it in SSMS, enabling an enclave. You can do it with PowerShell, Azure CLI, it doesn't really matter. There are several ways to enable your enclave. There we go, that's already done. Now, secondly, what we need to do is we need to configure two keys. We need to have a column master key that is going to be a certificate that is stored in my Azure Key Vault. And we need to have that column master key to encrypt the column encryption key. And the column encryption key is going to encrypt our columns then. Make sense? Yeah? So where do you do that? You can use T-SQL, or you can go here in the Management Studio. If you go under Security, you have a folder here called Always Encrypted, and I'm going to use column master key. So new key. I want to use, is this visible in the back? Probably not. So these are the options. So I'm going to choose for this demo Azure Key Vault. And I'm going to give it a name, which is called, oh, okay. I just need to sign in. No, I don't need this. Let me get back. All right. So let me give it a name. I will call it CMK. This is my subscription, and the key vault that I'm going to use is this one, and the certificate is the CMK key that is stored in my key vault. So the SSMS is connecting to my key vault and knows which keys are available and which permissions I have on all these keys. So this is the certificate, all right? Click OK. And once you've configured your column encryption, your column master key, you need to create a column encryption key. So let me call this CEK. And this is going to be encrypted by the column master key that I am just created. All right, that was step 2, creating 2 keys. Fairly easy to do. Now, next step, I need to encrypt my data, right? And there are several ways. You can use T-SQL, you can use PowerShell, but there is also a wizard in SSMS that you can use to easily encrypt your columns, and that is what I'm going to show. We did a lot of new investments in that wizard, and this is available in the new version of SSMS 19.2, which was released this week. Yeah. So I go to my table, employees, and here you have the option encrypt columns. And that's what I want to do. So first of all, you get an introduction, welcome screen. We also made the wizard smart. So I enabled the enclave already. Let's assume I didn't do that. Then the wizard will see that, and it will tell you, hey, by the way, you didn't enable an enclave. Do you want to enable an enclave, yes or no? I would recommend to do that because, as I just explained, you get much more flexibility. All right? So first step, you need to configure the columns. So let's go for Social Security number and salary, right? These are the sensitive information that I want to encrypt. The encryption type that you can choose is deterministic and randomized. Does everybody know the difference between the two? I see nodding. Yeah? All right, cool. So if you want to use an enclave, you always have to use randomized. You cannot use deterministic. Otherwise, you will not use the enclave. So in this case, I'm going to select a randomized. I'm already using the keys that I'm just created, so that's fine. Click Next. Master key, I don't need to have any additional configuration here. In-place encryption, no enclave attestation. We currently do not support attestation for VBS enclave, so we need to put this to none. Run settings, yes, I want to proceed and do this right now. The summary here, and here you can see that the operation mode is saying in place using a secure enclave. So we're not going to extract the data outside of the database. We're actually using the enclave. So I just click Finish. And then there we go. And now we're going to perform the encryption on the column. Hopefully it goes pretty quick. Now in the meantime, what I will do while this is running, we also need to change a little bit of stuff on the application side before we can use an encrypted column. So first of all, what you need to do in your application is you have to make sure that you're using parameters in your queries, like this here. So This is a query that is used by that website, so where social security number, like, and then a parameter, yeah? So this is necessary, otherwise always encrypted will not work. And that's the hard part when I work with my customers and they want to convert an existing application to use encrypted columns. I'm not going to say that it's going to be easy. So that's hard work and is not easy to do. All right? What else do you need to do is you need to change your connection string. So if I go to my application and I go to my configuration here, and here I have my connection string. So this is just a normal connection string, right? The server, the database name, and the authentication that I'm using. So I'm using a managed identity. What else do you need to add if you want to use always encrypted are these two parameters here. And I will just copy and paste them. So you need to specify column encryption setting equals enabled, which means I want to use always encrypted. Yeah. So at that moment, your client driver that I talked about will do the encryption and the decryption. And what else do you need? You need to specify the attestation. Like I said, currently for VBS enclaves, we do not support attestation. So it has to be set to a value called none. If you're using SGX enclaves, then you will have to use Microsoft Azure attestation. That's another service that we have. By the way, does everybody know what attestation does? No? It's an extra check that we're doing to verify whether the enclave itself can be trusted, so that nobody has tampered with the enclave. Yeah. So and that's what we're doing when, or that's for SGX. Sorry, we're using another service called Microsoft Azure Attestation to verify whether the enclave can be trusted. All right. So this is what you just need to add into your connection string. Let me click OK and do a refresh here. Yes, no problem. You can restart my web app. In the meantime, I'm hoping that my encryption is done. And that is done. So performing encryption operation, everything is passed. Perfect. Now, if I go back here to my query window, I'm still the DBA. And if I execute this query again, you can't see anything in any information anymore. It's fully encrypted.
So you just, how bad would it be if I remove people now?
Sorry, can you?
If you not drop the people, lose the keys, how bad is it?
If you're losing the keys, then you have a big problem. Yeah. Yes. Yeah. We're not, to be clear, we're not storing any keys in the database at all. Never, ever. What we store is the metadata. Where is my key? In Key Vault. So if you drop your key and you want to decrypt or encrypt and we cannot find the key, you have a problem. So yeah, definitely would not be good. Sorry.
So I believe it's a small data set, right? It took a couple of minutes, but what if you have a terabyte of data? It's going to take days, right?
What if you have terabytes of data? Yes, that can take a while to encrypt your column. That is correct. I don't have any information how long that would take, but it could take a couple of days.
Other question is, do you set up a encryption key on the column level? What if I migrate this table to other instance? Will this table work?
The question is, what will happen if you copy that table to another instance, right? That will work. But you will need to make sure that on that other instance or that other database, you have the same keys. And then you also need to enable the enclave, right? And you make sure that you have the same keys, and then that will work perfectly fine. The keys have to be in place there as well. Yeah, otherwise it will not work. Yes, sir? I'm sorry, you have to speak up a little bit more. Okay, if I understand it correctly, if you want to remove a key in the key vault, but it's linked here in the database, do you get a warning? No, not for the moment, no. No, no. So yeah, if you delete it there, of course, make sure in your key vault that you there also configure the correct access policies. Me as a DBA, I don't need to have access to the keys in the key vault. That's dealt by the security administrator, right? Sorry, if you query? Yeah. Now I'm wearing multiple hats. In real life, the DBA shouldn't have access to the keys. If you should have access, good for you, but then the whole purpose of always encrypted doesn't really matter, right? Because you can see the data. So yes, this called that, what is it? Separation of duties, right? The creation of the keys should be done by the security administrator, and the creation here can be done by the DBA, but it shouldn't be done. It should also be done by the security administrator. Yes, sir.
Change all this. How does it manifest itself in the application if the query isn't working? What kind of error do you get?
Oh, you get an error message back like this value is encrypted with algorithm AES256 and we cannot display it. Yeah, definitely. Yeah. Yes, sir. Or lady at the back, sorry.
What if it's a third-party application, it's built in-house with an application, it's a third-party, it's a vendor application. Do you have to work together with them?
Yeah. If I understand correctly, what happens if we have a vendor application? Yeah, you will need to work with them. They will need to change their code, for sure. You also have to make sure you use the correct driver version. So we support ODBC, GDBC, .NET. But if you want to support enclaves, you have to configure a specific version. I don't know them by heart, but yeah. But definitely, you need to work with the vendor. Yeah, for sure. Yes, sir.
So the restore, if I'm restoring the database, is this, it will override everything or it will keep as it is? If I'm restoring, suppose from the production to payroll, I have the encryption enabled, what will be there? It will be enabled. By default, I can see the data, I cannot see the data, what will be?
No. If you restore this on another server, you mean? And yeah, still, if you don't have access to the keys, you will not see the data. Never.
I have to maintain that connection string, everything again, to override it to see the actual user, right?
Yeah, that's right. Yeah. Yes, sir.
Is the encryption a locking operation?
Is the encryption, sorry?
A locking operation, the table lock while they receive?
No. What we're doing is we're creating a table next to the existing one. We're doing the encryption there. And once it's encrypted, we switch the table. Well, switching the tables, this is a short moment of locking. But while we're encrypting, you can still use the data.
So it's also by working with the transaction logs to pick up anything that happens to
Yeah.
take a while.
Yes. Yes.
Because I'm the same, but I have terabytes of data.
Yeah. That will work. Yeah. No problem. Yes, sir.
So does this work with like any framework and that kind of stuff on the software application side?
That's a good question. I've worked with a customer last week, and he was complaining about Entity Framework and always encrypted. I know. It's hard. Apparently, it's hard. I'm not going to lie. Yeah, it is hard to work.
Parameters don't work super great.
No, I know. Yeah, I know. And to be honest, yeah, I'm not against Microsoft at all. But for example, Power BI doesn't support always encrypted. Yeah, sorry, I know. We are discussing this for months with the Power BI team to support us. The problem is that they work on the number of votes, right? So the more votes you get, the faster it gets implemented. So if you want to help me, go there and vote and say, yeah, we want to support always encrypted. So yeah, I'm sorry, this is not supported. Maybe let me finish my demo. How much time? Oh, 25. I'm sorry? I will add a link to the presentation. That's a good idea. That's a good idea. Please all vote. Right, so the application, if I just do a refresh here, I'm not sure this is going to work immediately. If not, then I just, okay, there we go. this is the error message that you get, and for the sir in the back, right? So this is something, oh, something is encrypted, I cannot read this. Now, what I will do, let me just close this and go here and just quickly clear the cache of my database, and then, oops, go back here. And let's try that again. Come on. There we go. So the application can still see the data, right? Because it has access to the keys, and I have configured the connection string to use always encrypt. So the client driver is doing the decryption and the encryption. Yeah? Cool, huh? All right. Any further questions before I move on? Yes, sir.
If you want to access this data, which is encrypted through SSMS, and SSMS also route through that key and go to the data.
Yeah, a good question. Does SSMS support always encrypted? Is that what you're asking? Yeah. Yes, for sure. So what you need to do in your connection string, so if you go here and where is it? Connection, change connection. Under the options, you have a tab called always encrypted. So what you need to do if you want to use and if you want to see the data, then you have to enable like this. So you have to enable always encrypted. That is equally to the column encryption parameter that I've just configured in my application, right? And then the other one is I want to enable secure enclaves. And then you also need to specify your enclave attestation, which is currently none for VBS, right? And then you can just use, or you can, no. Then SSMS will decrypt and encrypt the information for you if you have, of course, access to the keys. If not, then you will not be able to see the data.
If I understand that enclave is like an envelope that goes around the database like that.
An envelope that goes around the database.
An imaginary kind of thing.
Yeah.
It covers that whole section of data and encrypts it. Is that what it is?
Yeah. Well, the data is encrypted inside the database, right? So, and before you can see that data, you have to have access to a key, right? It's like, you can compare it like you want to enter this room, but if you don't have the key, you won't be able to enter the room. Only the people that have the correct keys, they can enter the room, and same for always encrypted. The data, as you have seen, is encrypted in the data, but I don't have access to that key. So I can run a query, but I will never ever see that data whatsoever. If you look at the application side, that application is using a managed identity, and that managed identity has permissions on the key. So that's the reason why it can see the data. Yeah? All right. Sir?
If somebody accidentally deleted that key from key store, could that be restored by Microsoft on from a backup prior?
The key vaults, yeah, it depends. I think even on the key vault now you have soft delete. So if you delete a key vault, you can still restore it for a couple of weeks, and then it will be removed. Even I think if you didn't enable that soft delete and you call our support, that they will be able to get it back. Yeah. But I think, to be honest, it's faster to just create a new key in another key vault. That will be much faster.
I'm just thinking if it's encrypted in there, you would need the same key to get it unencrypted, right?
Or you do the key rotation, right? And it depends, of course, how many data you have. But if you configure quickly another master key, you just need to do key rotation, and then your data will be good to go again. Okay. Yeah. Yes? The key on the application side? Yeah. Yes. Yeah. Where's, okay, the key, all right, okay, I got your question. Okay, let me go to the application. So the application is going to look for a key in the key vault, right? So if I go to my key vault here, this is the key vault. So this is my CMK, right? This was the key that I've configured. Now if I go to the access policies, and here you have that data encryption demo app. That is my application. So I've created a user-managed identity for that application, and it has the permissions unwrap key, verify, and get. So it means that it can fetch the correct keys in the key vault. Yeah, and so that is how you configure that key permission. Okay? All right. Yes?
So the data encryption demo app, that's your application or the login that you're using for the database?
Sorry, can you repeat your question?
So the demo app that has the unwrap key, the verify and get.
Yeah.
Is that allocated, is that assigned to the actual application that you have?
Yes.
Or is it actually just a login to the database?
This here is a managed identity that I've configured. So managed identity is, yeah, you link it to your application and then you can provide permissions to that managed identity. So that's how I did it. And then, yeah, what you then do is you consider that all the users that are using this application can also be trusted, right? If you don't want that, what you can also do here, like below the last two, this is my account and from a colleague of me, you can also do that. You can just say specific users have these kind of permissions. And that's also something you can do. But that's up to the security administrator to define how you specify the permissions on the keys. All right. Cool. A lot of questions. I like this. Okay. What do you think of Always Encrypted? Was it easy to configure, do you think? Easy configured, no? All right. More maintenance? Yeah. Then you need to make sure that the keys. By the way, this also supports GODR. So if you want to replicate your database to another region, we support it there. Just make sure that the DR region also has access to the keys, of course. Yeah. Yes, sir.
I'm sorry, a dumb question. I know this is on Azure and Azure databases, but did you mention that it is available with SQL 2022?
Yes.
On-prem?
On-prem.
Oh, awesome.
Yes. SQL 2019 and SQL 2022, you can use VBS enclaves, not SGX enclaves. And the same kind of functionality you have there. For MI, you only have always encrypted, so not the enclave support. We're working on that, so hopefully we can. I'm standing here next year and saying something else, right? Yes, sir. Maybe last question because we have one other topic.
What is the limitation in the queries when using the enclave?
What is the, yeah, like I said, you have to use parameters. If you don't use parameters in your queries, then you will definitely get error message because we're encrypting the value that is inside your parameter. So if you use hard-coded where equals XYZ, that's not going to work. So that's the implementation that you will have to do. All right? Okay, cool. Let's move on to another favorite topic of me, which is called, yeah, we have some, okay, some marketing stuff, sorry. We also have customer stories. So Royal Bank of Canada is using Always Encrypted, and Loyal Health is one of our biggest customers. They are in healthcare industry, and they are basically an ISV that's creating an application that is used by hospitals, and they are using Always Encrypted very intensively. So these are two use cases. If you go to these links, aka.ms/loyal case study, you get the whole story, what we have done there together with that customer. All right, I'm going to skip that. Ledger, the third topic of today. Who hasn't heard of Ledger before? Oh, wow, then I didn't do a good job. Okay, damn. No, ledger is all about data integrity. And what I mean by that is, how can you be 100% sure that the data that is inside your database can be fully trusted? To give you an example, in my previous life, I was a DBA. And typically, DBAs, they get system administrator permissions, right? So what I could do, I could easily go into every single database, run a query on the salaries, for example, look up my own salary and add like 5,000 euros extra per month. Nobody would have ever noticed that I have done that, right? True, yeah? Okay, so our customers, they were looking into technology. Some of our customers, they had that same problem, and they were looking into blockchain technologies. And they were like, oh yeah, let's go to blockchain. It's fancy blockchain. But they hit the limits of blockchain. It's kind of slow. It costs lots of money. Not many people know how to implement it in a production environment. So yeah, so that's why we introduced Ledger. And Ledger is all about capturing what is happening on your tables and cryptographically link those transactions to each other to make it tamper-proof and to make it easy for you to prove that your data is not or has not been tampered with. Yeah? So we have the concept of ledger tables. I'll come back to that immediately. Yeah? It is inside SQL, so everybody that knows SQL can use Ledger. You don't have to enable it. It's just there. You just need to create a ledger table. It is available in Azure SQL Database and SQL Server 2022, not in managed, in Azure SQL Database and SQL Server. And I'm happy to announce that this week we have also introduced Ledger in managed instance. So we cover all the flavors of Azure SQL. So we wanted to support that everywhere, and we finally were able to do that. So happy to announce that. Now, what are the use cases for Ledger? Like I said, streamlining audit compliance. So if you have to prove to an external auditor or regulator that your database has not been tampered with, use Ledger. Yeah? It will make your data tamper-proof. Another use case that we see is multi-party systems. For example, supply chain, where your data is centralized, so you're using one specific database, but you will need to prove to different parties that nobody has actually tampered with your data, right? So these are typical use cases that we see. Yeah? All right, let me jump in a little bit more into detail how Ledger works. So you have the concept of a ledger table. And we have two types of tables. We have an updatable ledger table and an append-only ledger tables. Let me start with updatable ledger table. So it allows you to do updates, insert, and delete statements on a ledger table. So let's assume you have a user, and that user performs an update on a specific row. Now what we're going to do is we're going to take that update of that row, and we're going to store that in a history table. And on top of that, we're going to add some extra metadata, like the commit time of the transaction, the user that has executed that specific transaction, and the transaction ID, right? Now, people that are familiar with SQL, they're probably coming to me now, yeah, but we already have this. This is temporal tables. Everybody heard about temporal tables? Yeah, that's true. So we based ledger tables on the technology of temporal tables. But what temporal tables does not have is the cryptographic proof, right? You can easily delete from temporal tables. You can tamper with it. You will not see, that. So that's why Ledger is much better than temporal tables. On top of that, so when you create an updatable ledger table, we're automatically going to create that history table for you, which will have the same schema as your table. And on top of that, you get what we call a ledger view. And a ledger view gives you a chronicle overview of your data. So basically, we're combining your production updatable ledger table and the history table. So you don't have to create that. If you don't specify the correct name, then we're going to use, or we're going to specify a name for you, but you can change that. All right? So this is how we keep track of all the changes that are happening in your database. Do you mind if I just finish everything and then, yeah? Yeah, sorry, otherwise I'm right in my flow now, and otherwise I need to. Okay, no, so this is how we keep track, but where do we keep the cryptographic? Well, what we're using is we're using a blockchain technology under the covers. So what we're doing, all these transactions that are happening on the system, we're going to encrypt them and we're going to link them to each other in what we call a block or a blockchain, right? And that is what we call the database ledger. This is fully transparent, so you don't have to worry about anything. We're doing that for you, yeah? So every 30 seconds, what we're doing is we're going to take all these transactions that have occurred during these 30 seconds, and we're going to generate a block from them, and we're going to link it to the previous block, and then we're going to store it outside of our database. And that block, we call that a database digest. And we're going to store that in trusted storage. And what do we consider as trusted storage? That is Azure storage account with the immutability settings switched on. Or we also have another service in Azure called Azure Confidential Ledger. That's nothing to do with ledger in SQL, but that's another service where you can store these digest files. So that is something you can choose, right? Now it becomes interesting, right? Because we have stored these digests outside of the database. So if an auditor comes by and wants to verify the database, what we can do is we will fetch the digests that are on the trusted storage. And in real time, we're going to recalculate the digest or the blocks inside the database, right? This is done by a specific stored procedure that we have created. And once we have executed that, we're going to match these two hashes. And if we have a match, then we have cryptographic proof that nobody has tampered with our data, right? Because there is a match. If we don't have a match, then we are also 100% sure that somebody has tampered with our data. And it will show you also in which transactions somebody has tampered with the data. Do you know who has tampered with the data? No, but at least you know that your data cannot be trusted. All right? Question. Sorry, you had a question.
If you turn on Ledger, do you automatically get temporal tables too?
If you turn on Ledger,
Yes. If I start using Ledger, do I also get the temporal tables so I can get them also?
I'm sorry, I don't know, if you use a ledger table, if you get temporal. Temporal tables already exist since SQL 2016, I think. If you turn them on, if you create a temporal table. Yeah. But here you have to create a ledger table, not a temporal table. Yeah.
If I create a ledger table, temporal tables, can I go and look at them just as I would?
Yeah, these are two different things. Yeah, yeah, no problem. Yes, sir. CDC is, no, it's capturing the changes, but again, it's not tamper-proof. You can change whatever you want. So this is really about proving that your data can be trusted. So that's why we have that encrypted technology. Yes. Sorry.
So I want to use this scenario at my job. We have a maintenance window for just every week. Let's say you have terabytes of data and you want to encrypt a column, but you know you don't have, and you can't encrypt all that in your maintenance window that you have. Is there a way you can encrypt like half of the table or the column and come back next week to do that?
Okay, so now you're talking a bit about always encrypted, right? All right. Okay. Sorry, we're just jumping back to always encrypted. No, you cannot. So it's a whole column or nothing. So you cannot say, okay, I'm stop there and then move on the next day. No, that's.
You just have to set it for windows.
Yeah. Yes, that's right. Yeah.
But again, it's not a non-blocking event, so.
Yeah. Exactly. Yeah. That's right.
I'm bringing it back to Ledger. So once we enable Ledger on our SQL server, I know you have the update table and the home point. Whenever you don't want the Ledger on the table anymore, will it still be there for like a lifetime? So for instance, you want to drop the Ledger that we already created, will it still be there or will you get rid of it
Okay.
if you need to?
Very good question. So the question is, I created a ledger table, but I want to get rid of it. I want to drop it, right? You cannot. So once you create a ledger table, you can drop it, and you will not see it in your database schema anymore.
I want my question. So, is there like a
hold your question. All right? So first question is, can I drop a ledger table? No, you can't. Well, yes, you can. You can say drop table, but we're not physically going to drop the table. So we're just logically going to drop it. It will stay on disk, right? Why? Because we need it. We need, if you create a ledger table, you won't be able to delete it because we still need to run that verification, right? That's why, I don't know if you've noticed it in the SSMS or in Azure Data Studio, you have the option dropped tables, dropped ledger tables. So you will find that table there. The other question was, can we have some kind of truncation, or I call it a retention period, right? So like you say, data that is older than 3 months, let's remove it. Very good question. I get it every single time I present Ledger, I get that question. And we have listened and we're looking into it for the moment to have this kind. But it's not, it looks maybe easy to implement it, but it's not, because let's assume you change the retention period to 1 day. You can do that, right? So you tamper with the data, and after 1 day, everything is gone. Nobody have seen this. Plus, on top of that, you need to be able to trust the delete mechanism, right? And you have to make sure that it only, so it looks easy, but it's definitely not. But I hear you, and we're looking into it. Yeah.
But isn't, like, when you guys implemented the ledger thing, isn't it what's supposed to compete with temporal tables? So wouldn't that be like one of the things you guys should look at?
If it competes with temporal tables, no, we're not competing, because this has the cryptographic proof. Temporal table doesn't have it. Temporal tables do have a retention period. Yeah, we don't. No, because of the nature of Ledger. Okay, 2 more questions, and then we have like 15 minutes, and I still need to show my cool demo on Ledger. Yes, sir.
The trusted storage, you mentioned 2 Azure-based solutions. What about on-premise?
Yes. Yes, good question. What about the trusted storage is both in Azure. Currently, we don't support any warm device on premises. So if you're using SQL Server and you want to use this mechanism, you will have to, or you will need to have access to an Azure storage account. That's correct. However, I've wrote in English? I wrote a blog post about it, where you can use SQL Agent to store the digests on a warm device. So because that was a question that I got a lot from customers. So that can help you to get started. So you can generate these digests manually by a job, and then fetching them back again if you want to run the verification store procedure. It's the blog on the tech community website. All right? Yes?
What is that, your tables are part of the replication?
The table cannot be part of the replication. That's one of the limitations. Yeah, it can be part of an always-on availability group, but not replication. That's not supported. Okay? One last question. I really need to jump into my demo. Okay.
Schema changes. If you're making a change to the main table, do you have to also make a change to ledger? Or does it automatically?
Yeah, the question is, what about schema changes? Good question. Adding columns is supported. So you can add columns. We are automatically going to change the history table as well. The only limitation is that it needs to be nullable column. Otherwise, it's not going to work. Dropping a column is also possible, but then again, we're not going to physically drop the column because we're not allowed to, because we still need to verify the data. That is possible. And modifying a column, it is possible, but quite limited. For example, you can change the var character from, let's say, 100 to 250. That is possible. What we don't support is changing the type, right? Changing from integer to var character, that would have an effect on the ledger itself. So that is not supported. Also, converting an existing table into a ledger table is not supported. So you will have to create a new ledger table and then copy the data from one server to another. All right? I know you have a question. Can I first do my demo? And then we can go have a drink and you can ask me whatever you want. All right? Okay. I'll come back to that later on. Let me first jump into the demo. No, I need to go, sorry. All right, demo. Let's imagine we're all in a hospital, right? And we're in Contoso Clinic, and Contoso Clinic is using an application to store patient information, quite sensitive information, and we need to make sure that data is tamper-proof. So they're using an application called Patients Hub. And for this demo, I'm going to use 4 different types of people. We have Christina. She's the patient. As you can see, she is in a lot of pain because she just had a knee surgery. So then we have Betty. Betty is a nurse that is also using the Patients Hub. And we have John. He's the DBA of the company or the hospital. And then we have Michael, and he's an external auditor. All right? Now, like I said, Christina, she's in a lot of pain, and she wants more painkillers. So she goes to the doctor, and the doctor says, yeah, sure, okay, you can have more painkillers. And the doctor advised Betty to give more painkillers to Christina. Now, if we jump to my application here. So this is what Christina sees, yeah, and there you go. Here we have Vicodin, and the refills that she got was just 1. But for Christina, 1 is not enough. I need more. All right? So, oh, by the way, what I forgot to mention is I'm using SQL Server 2022, not Azure SQL, not managed instance. All right? So, Betty, who is the nurse in the hospital, she also uses the Patients Hub, and she looks up the record of Christina here, and she sees, all right, Vicodin, only 1 refill, but let's change it to 4. You get 4, right? So update was successful. Now, all this information that is used by the application is stored in an updatable ledger table. So if I go now to my, Azure Data Studio. So the update that Betty just did is stored in my ledger table. So here you can actually see medications, and as you can see here, it is an updatable ledger table. So if you open this, then you have here also the history table, and if under views, there you will have the medication ledger view. So I'm using that view here to fetch the transactions. So let me run this. And what you can see here is the update that Betty just did. An update is stored in the history table with 2 records. One, which is the delete of the old version, and then we have an insert of the new version. And what has changed is indeed the refills. You can see it here from 1 to 4, right? So this is how we keep track of the history. So every single update, insert, delete statement is stored in this updatable ledger table. All right, now, Michael, he comes along and he says, okay, let me see if the data can be trusted. So we have, like I said, a special stored procedure called SP verify database ledger from digest storage, which is going to verify whether the data can be trusted. Okay, so let me run this. And the verification successfully verified up to block 3. This is the digest storage that I'm using, and the result is ledger verification succeeded. So here we have cryptographic proof nobody has actually tampered with the data. Cool. Now, Christina, she's still in a lot of pain, and her friend John, he's the DBA at the hospital, and she's asking, hey, John, can you do me a favor? Can you give me more refills? Because the doctor and the nurse, they don't want to give me more. And John's like, yeah, sure, I can do that. So he, John, he's a DBA, and he's like, okay, I can do that, but he sees that this is a updatable ledger table, so his changes will be tracked, and he doesn't want to do that. Now, John is smart, and he's like, okay, you know what I'm going to do? I will write a stored procedure that goes around the ledger, and I'm actually going to modify the data in the data page on disk. So I don't need SQL. So it means that it's not going to be captured by the ledger, right? So John is looking up the patient ID, and he knows, all right, it's order medical ID 2 that I need to update, because here he sees the refills of 4. So he wrote a stored procedure called SP tamper with medications, the ID, and the number of refills, 20 instead of 4. All right, let's do this. It has been executed. Now we go to, again, to the medications here, and what we see is that ID2 has now 20 refills. But this is not stored in the ledger because we wrote it immediately to the disk on the data page. All right. Now, Michael comes in again, the auditor, and he's like, okay, let me verify if my data can be fully trusted again. So he runs the stored procedure. And what happens is, boom, a lot of error messages. The computed hash for medications in associated history table do not match in transaction 7375. So it means that at this point, I have cryptographic proof that somebody has actually tampered with my data. Now, I can look up the transaction ID here. There we go. And here you can see that this specific record here was or has been tampered with, right? And so, yeah, what I mean is here you have the cryptographic proof that your data cannot be trusted. Cool, huh? Yeah. Now, tampering in Azure SQL or managed instance is much harder because you don't have access to the data files. Yeah. But still, you can run that verification stored procedure. In SQL, like I did, you have access to the data files, so you can tamper there. But Ledger captures that. All right. Let me quickly jump back to the presentation. Sorry. Some customer stories or customers that are using Ledger. I just want to focus on Lenovo and Code. So Lenovo, everybody knows Lenovo, right? They're using Ledger to store configuration parameters of their laptops. So when you order a laptop and you receive it, they are running a verification to verify whether you received the laptop that you've actually ordered. Because apparently, in the middle, when there is some kind of vendor, sometimes they just open up the laptop, they change the CPU, and then they send it back. So that information had to be trusted. And Code is a customer in South Africa that we've worked with, and they were storing the COVID vaccination status of every people in South Africa in a ledger table. So that also had to be tamper-proof. So these are just 2 use cases, and the links are there below if you want to read more over the weekend. All right. And I think I'm done talking. So what have we seen? 2 encryption technologies, TD and transparent, TD, which is transparent data encryption, and always encrypted. And last but not least, I've also showed you Ledger. There is documentation. There are videos about Ledger and always encrypted on Data Exposed. Do you all know Data Exposed with Anna? No? Yeah? All right, there you have also me talking about Ledger, talking about always encrypted. Feel free to contact me if you have any particular questions or use cases. This is my email address. I'll try to respond as soon as possible. And please, one last request, fill in the evaluation. I want to know if you like this or not, if I can improve this presentation or not. And once again, thank you for coming, and hope you've learned something.